Hi YouTube, this is Core 4 2012. Question 1, partial fractions and integration. So for part A, given the form required, multiplying both sides by the lowest common denominator gives the identity here, and trying x equals a third, the constant and the coefficient of x squared gives values for A, B and C. So using this result for the integral in B for the general solution, the first two expressions are the ln type and the ax plus b to the power n type for the third expression. So we can write down the general solution. And then using this general solution to evaluate for the limits, evaluating gives an area of ln 4/5 plus 3/10. So the partial fractions, the integral given, the integration, and the exact value. Question 2, calculus rate of change. A cube to show dv dx is 3x squared in A, and then given dv dt, to find dx dt when x equals 8 in B, and to find ds dt when x equals 8 in C. So for part A, from observation of the sketch, the volume is x cubed, so dv dx is 3x squared. So for dx dt in B, dx dt will be given by this expression, and given dv dt and using dv dx from A, applying to the expression for dx dt and substituting x equals 8, evaluates to dx dt as 1 over 4,000. So to find ds dt in C, the surface area will be 6x squared, so ds dx will be 12x. Given that ds dt will be this expression, we can use our result for dx dt and substitute x equals 8 into ds dx, which gives ds dt as 3 over 125. Question 3, binomial theorem. The binomial expansion for f of x in A, B and C to determine x cubed. So for the first expression, taking out a factor of 6 and applying the binomial expansion and simplifying gives the expansion required to x cubed. And for part B, adjusting our result from A for positive 4x and simplifying gives this expression. And similarly for minus 8x, substituting and simplifying gives an expression required. So for part A, the expansion, and for part B, and for part C. Question 4, a differential equation, particular solution. From observation, we see it separable, so separating, integrating both sides, and simplifying gives us general solution. So given y equals 2, x equals pi over 4, substituting in the general solution gives a value for the constant, and simplifying our general solution with the constant gives the particular solution y equals root 6 tan x minus 2. The general solution, the particular solution. Question 5. To find dy dx for the curve in A and the coordinates where dy dx equals 0 in B. So applying implicit differentiation, simplifying and factorizing gives an expression for dy dx. So considering the stationary points for 0, then 18 minus 6xy will be 0, and xy will be 3 and y 3 over x. Substituting y equals 3 over x in the curve simplifies to x to the power 4 equals 16, given x equals plus or minus 2 for the x coordinates. Substituting these values in xy equals 3 gives values for y and the 2 coordinates required. So the implicit differentiation and the coordinates and a sketch here shows the curve with the 2 stationary points. Thank you for watching. I'll start question 6 in the next video.